today, bud?
Hey, how are you? Guess what? So I've come with a different problem today. I was talking to a customer the other day, and they were struggling with getting value out of their data science models. And the whole point of data science is to learn from history and then take advantage of that insight in real time and future, right? So, for instance, this customer that I was talking to, they have manufacturing plants across a specific geo. We won't go into those details, but in their manufacturing plants, what do they have is like, where if the temperature of the machines go above a specific threshold, then the chance of equipment failing in 8 hours is significantly high. So now that they have this information, how do they make sure the predictive maintenance is done in time to avoid costly downtime? And another problem that they are dealing with is like in their organization, data scientists have come from different background with different skills, so they come with different tools. So all of them use different tools and hence create different model types.
Oh, okay. So like what kind of model?
They end up with various types of models: Python, R, H2O, PML, etc. And the application development teams, they struggle operationalizing these models. And as the famous saying goes, right, the Ferrari remains in the garage, and the models, the insights are never leveraged at all.
Wait a minute. He has a Ferrari. Like, if I help you fix this problem, can I drive the Ferrari?
Real funny. Can you help or not, doctor?
Of course I can. Of course I can. Do you have any of their models yet? I have some models I can show you, and then you know, the idea is I teach you to fish, and you go do your thing. All right. So
Sounds
you
like
want to
a plan.
do that? I'll show you one of my models.
Yep.
Okay. So here's just before I share my screen and show you my Stream-based studio. What we're going to do is we're going to take a model, and we're going to score the streaming data against that model. But in order to do that, ideally, we get a model from, you know, one of our data science friends, and our data science friend has to give us additional information, such as what does the model expect in for schema, and what is it going to generate out. And really, in an ideal world, maybe they even give us a data file that they use to train that model.
Okay.
So if you, in an ideal world, when you go back to whoever you're dealing with, you'll get those things. Okay.
Correct.
So on our input stream, we need that schema. So let's start. I'm gonna I'll show you a data set that I have that I got from a data science friend. And, you know, all transparency here, I am not a data scientist. I don't even play one on TV. But so I have a data file, and I have a model, and I'll walk you through how I configure the model operator.
Sounds like a plan.
I want to show you. I'll show you in general, right? There's different model types. You mentioned a few, and I'm going to show you my one PMML file. Okay.
Why PMML? Any specific reason why you choose that?
Yeah, so PMML is fairly human readable. So I said, oh, you need to know what the model expects in and what it's going to give out. If you have a PMML model, you could most likely discern those details.
Okay.
By reading the PMML file. So let me show you. It'll make more sense if I show you. Let's do this. Okay, so here's a PMML file that I have, and up here at the top we see that there are 16 fields. All right, so this is the first clue you're looking for. What does the schema look like? How many fields are in the schema? It is literally in this tag, data dictionary, number of fields, 16. And then it itemizes what are those data fields, and for each one of them, what type is it?
So this is essentially defining what's the input schema. So based on what fields our model is going to make a prediction.
Yes.
Okay.
There's a little trick here, in the sense that one of these fields is actually the output. And I'm not I'll say it again, I'm not a data scientist, so I can't necessarily tell right off the top of the bat. I know because I've worked with this PMML file before, that this particular field is the output for this model. But what I can do, what my data science friends have taught me to do, is that if we look for a tag of output, a lot of times, just like there's this data dictionary tag, there's another tag called output. Now, this particular file doesn't have an output, but there is another tag that we can look for. So there's another tag. If your PMML doesn't have the output tag in it, there's another tag you can search for called target variable name. So if we search for that in this particular file, let me move my search box over. Sorry. We see that, come on, where to go? Find next. Here we go. We see that our target variable name is customer status. So now we know what our schema is. It's those 16 fields in their data types. And we know that our output is going to be the customer status. And again, if we look underneath this portion of the PMML, we see that customer status is the predicted value. And all these other field names have a different, are marked as active.
Again, you're being modest, right? By saying I'm not a data scientist. You're almost a data scientist now.
Maybe that'll be my next degree. Right now I'm working on something else. So, all right. So given that PMML, all right, let's go to Studio. Let's go to my Studio, and let's talk about this project that I have open on my screen right now. Has in it the data file. Okay, so this project has in it, in the source main resources, we've talked a little bit on some of our other sessions about the organization of projects in Stream-Based Studio. And so this data file is a data file that came with this model. And so if we look at that data file, we see across the top all of those tags inside our data dictionary, if we put them side by side. And so I have the data file. I've used the data file to create my schema. So I have this SB int, and again, from a good programming, we like to emphasize we do the right thing. So from a good programming point of view, I've created a name schema in a .sb int. So my interface file I can share with others and reuse. And if we hover over this, this particular schema, name schema, it says it was generated from that data file. And again, I'm just going to point out that my schema has in it the customer status, which is going to be the predicted value. And this is often the case, right?
So Lorinda, all right, wait. Lorinda, I'm going to interrupt you here. I think both of us have this tendency of forgetting that there is an audience watching here. So just FYI, everybody who's watching, what Lorinda is saying is that she did not create the schema manually. All she had to do was just click on a few buttons, and based on the Excel file that she had, this schema was automatically created.
Right. So, okay, I'll do that. I'll show you real quick. If we add a name schema, sample schema, and I can use this button over here, copy schema from, and I can pick my my CSV file, and it loads a CSV file in there. I have a header, so I click the header row, and then we see each of those headers from my data file, which is what's in my PMML file, and it determines the type of each of those fields, and I can say okay, and then I have this schema generated. So now I have two here, a sample schema that I just created that was generated from the CSV, and previously I had this one. And I should have said to Manish, this data file is a whole bunch of data from past purchases, and we're going to predict whether the customer is likely to stay with us or whether to, in sales terminology, it's called churn, leave us and go to another vendor. So So we have our name schema, and we put that schema on our input stream. I've also created a feed simulation that's going to open that data file and pass the tuples through. So we'll have a tuple source. And the very first thing we're going to do is we're going to remove the customer status out of the stream, because that file came to us from our data science friends. It was the file that was used to train the model, and then they store the predicted model back into the data file. That's a very normal thing to do. But for us, we want to generate that value new. So I'm stripping off from our schema the customer status. Okay, that's the very first thing I'm doing here. And then the next
so
thing
in a real world application, I mean, just for testing maybe, but in a real world application, this data will be coming from some real-time source, and I will not have this value, and I won't have to remove it.
Correct. Correct.
Yeah.
All right. Yeah. This is why you're my favorite student. Okay. So so the next thing we need to do is every model operator is a little different, and we can again, I know a certain amount about the model operators, but our documentation set tries to help people who maybe don't know so much about the model operators. But the PMML model operator expects the tuples to come in a top level tuple named frame. So let me see, I'm just gonna show you the doc page for that so that you would know yourself. Instead of taking my word for it. Okay, the data input port, here we go. We have to pass in something named frame, and this is our tuple or our list of tuples to be scored by the deployed models. Okay, so the very first thing we're going to do, and this is the same pattern for all of the model operators, is you almost always have a map operator that is going to put the data in the form that the model operator wants or needs it in. So what we do is this syntax here, we're adding a variable called frame, and underneath that variable, the dot star notation says star matches everything. All right, so that's our wild card. So basically, if we take everything off of our input stream and nest it underneath a top level thing called frame. So I really want to focus over here on the bottom right hand corner, the streams pane of Stream-Based Studio. What we got into, if we click on the input tab, what we got into this map operator were all these fields at the top level. And now we can look at what we're going to send out. We can see we're going to send out this thing called frame. And if I expand it, then I see all of my data fields nested underneath there. Okay, so that's what we need to pass into the model operator.
Makes sense.
Now, you might also be wondering why I have this other this other line. This is again a common pattern is that you take all of your original fields and nest them underneath. The model operators often can do what's called a pass through. And so if you're not, the model operator will be looking for something called frame, and everything else will get passed through. So I'm taking all of our tuples, and it's a little bit redundant here, but again, sometimes this is desired. I'm taking all of our fields and I'm nesting them underneath a tuple called orig, as in the original, and we're passing that in. So now that our data is in shape, we pass it to the actual model operator. And on the model operator, there's a couple things we need to configure. The first one is, what is the actual model we're going to run? Now, again, these tabs in the configuration of a given model operator is unique to that model. So we'll look at a couple of those depending on how much time we have. But on PMML, we say, where is the model that I wanna execute? And so this syntax here is, I say my model lives in a file, and I'm giving a relative directory within my project, And so if we look over here under source main resources, I do have a models folder, and underneath the models folder, I have a couple different PMMLs. And so I'm naming one of those PMMLs. This is the file I'm going to actually use to do my scoring. Then the other tab that we're really interested in PMML configuration is the schemas. And this is the output schema. And again, we would know that if we looked at our documentation set. So basically, our output schema is, we don't have to name the input schema, but we do have to name what we expect to come out. And so we're expecting a field named customer status, and it's of type string. And again, I knew that because I showed you that over here in the PMML file, and or your data science friend told you that. Okay.
So I'm guessing that name has to match. So you'll have to know your schema, and okay, and accordingly you'll have to create that out of the schema. Okay.
And it's a little more complicated. If I threw the doc page back up, you would see it, or you can again rely on your schemas tab, your streams tab over here in the bottom right hand corner. With your focus set on the model operator, if you look at what is the model operator going to output, we see it's going to output that original tuple that we passed in there, the pass through, and then it's going to output a list of scores. And if we expand the list of scores, then we see that there's actually a single score tuple. Within that score tuple is this customer status that we really want. So although we know that it's going to output a string called customer status, that string is nested. And so we have to extract it out. And so again, going back to the pattern, almost always after your model operator, you will have another map operator that's doing that extraction. So if we put the focus on this map operator that I've called unpack, and we see what's the input, I don't care about that original tuple, but I do have this list of scores, and there's my score tuple, and there's that thing right underneath there that I want to pull out. So how do I formulate that expression? For a list, we have like an array offset, right? Just like doing array math and typical computer science. Yeah. So at the 0th offset, so the very first thing in the list, all computer nerds start counting at 0. Go get me the field name score, and within the score, give me the customer status. And so I access that particular field, and you'll notice that within Studio, that font is maybe like purple, kind of pink and purple. That means it's a known value out of our known schema. And I'm going to assign that to this particular field name, and then I'm going to print it out. So so here's our pattern. You pack, you call the model, you configure the model operator, you unpack. Make sense?
That's awesome. So essentially, if I go back to the customer that I was referring to in the beginning, what they can do is they can operationalize their models in this kind of a real-time application and take advantage of their insights. And I think just to remind everybody in the audience who's watching, I think we are using PMML as an example. There are various types that we support, including R, Python, H2O. Right, Laura?
Right.
Anything else?
And that there's even within PMML there are some differences. So if we look, I have another model in my editor right here, which really does have the output, right? I mentioned in this model we don't have the output tag, and so we had to search to find our output, and we searched on target variable name. But there are some PMMLs that explicitly name the output. And now, if you look at this PMML, it's outputting 3 things. And so this particular model is predicting whether someone is likely to buy a certain type of clothing based on their previous purchase history. And so it's going to output the probability of 0 and the probability of 1, which added together should be 1, as well as a string field. So you know, even though I showed you the 1 PMML, the best thing is if you really can work with your data science friend and know what the model wants and is going to push out. Because it really is a contract, right? So our model operators, well, it's really the model. The model has a contract. And if you don't pass the correct things in, then the model won't be able to do its job. And so if you just really concentrate on thinking of it like that as a contract, I can show you.
And before we move further, so all of this is happening in line, right? So there is not a call being made outside of your current context, like the streaming context. So there is, like, for example, if I'm dealing with a really low latency application, then I don't have to worry about performance.
So yeah, we can do other model types, and we can look at, so I have, this particular project is using a TER, and then I have an H2O sample that I can show you as well. And the pattern is always the same, but yes, they're being streamed inline.
Okay.
They're being called in the stream, right, as our tuples flow from left to right. They get scored right then and there. Now there is, you know, there is a way. Every single one of our operators has this concurrency tab. That's a very advanced topic that maybe we could tackle one day. But for right now, for the sake of this conversation, and your comment about low latency, what I will say is that if your scoring is taking longer than your application wants based on its latency, we can make the scoring operator be concurrent and run multiple versions of it. Those issues.
That applies to any operator in the streaming sort of event flow, right? So, I mean, most
right. Like
operators
if I click on some operator, almost every operator has this concurrency tab.
Right.
Now
right. If there is a bottleneck, there is a way around it.
Yeah, there are some design implications with that. So I don't, you know, we often, when I teach, I say do not turn on concurrency for a single operator, but rather for a module that's doing some amount of work where you have, and you have to have the back end resources to actually be able to run things concurrently, which means your machine needs to be provisioned with enough cores, with enough memory, etc. But you're the one who mentioned low latency, so just pointing that out.
I won't bombard you with further questions, but yeah, I just wanted to put it on our sort of further to-do list. So maybe in future we'll do a session on this topic. But please continue.
Sure. So TER has its own unique kind of settings, and so for TER, your top level variable has to be this thing called TER vars, and then this particular model, and again, I'm gonna get rid of my editor right there. This particular model, I know that the top level, the model expects something in called new data. So my data file that my data scientist gave to me has all these variables. This one is like the worst names ever, but we had to anonymize the data. Okay, so basically there's 8 data fields. One of the 8 can be predicted based on the value of the other 7. And so our schema here is this generic var 1, var 2, up to var 8. And you'll notice that var 5 is missing. And var 5 is the variable that can be predicted based on the other 7. And this model expects all those fields, those 7 fields, to come in nested underneath of something called new data. And my model operator expects the whole thing to come in underneath this top level name of TER vars.
How the PMML operator expects everything under frame, in TER it expects under TER vars.
Right. And so if we were to, okay, so if we looked at the doc set for the TER operator, it tells us that we need an input tuple called TER vars. and these then the fields underneath there are converted for use by the TARE operator. So there's a couple. So the first thing we do in our pattern for TARE is we map into the top level TARE vars, and then maybe there's another level of mapping based on the model. And then the TARE operator itself, we have several different tabs that need to be configured. And the first one is that within TARE, you're going to be calling a script. And so on the operator properties tab of the configuration, we name that script. And not only do we name the script, you have to pass in the variables that it expects. And then it's going to, generate you a score, a prediction or whatever, and you need to name the variable into which you're going to put that score.
Got it.
Okay, now on the schema tab, this field needs to match what you had on your properties on your script tab, right? So we're calling this script and we're putting into the field output the results of calling the script. And so on our edit schema, we declare that we have this variable named output and what's its type. And then there's an initialize tab. And on the initialize tab is where we name the model that's going to be used. So again, this is just how TARE works, and it's different, and therefore our model operator has to be configured differently to use this particular type of a model.
Got it.
Okay, and after we're done, and again, if we put our focus on the model operator and we take advantage over here, we can see that the output is going to have something called TARE data. And if we expand that TARE data, then we see our output tuple of type double. So our unpack, or in this case, I called it extract after the fact, we're gonna promote that field back up to the top level rather than leave it nested underneath there. So we take a look at that, and sure enough, we say, give me my TARE data dot output and promote it up. And as I said, this is like not very good names, but variable 5 can be predicted based on the other 8 variables or the other 7 variables in the data set. So, all right.
And so let's say I have an application where multiple models are coming in. Like in my real-time application, I'm making some predictions based on one model type. So my TARE, H2O, PMML, all of this can coexist in one application, right? So in the event flow that we are seeing right now, I can have as many models of as many model types that I want, correct?
Absolutely. So I mean, I have each one here separately,
yeah.
But let me show you H2O as well. All right, hold on one second. So we see the same pattern. We pack, we call the model operator, we unpack. So each one of these is in its own module right now, but you could have your input stream, and each one of these is using a different model. So this is a little bit of a false equivalency here, but I could split, let's say they were all using the same schema. I could put a split operator here, and if you had 4 different model types, I could say, let me split my stream 4 different ways, and I could have 4 different packs where each pack was putting it in the format for that specific model operator, right? So here I'll just show you. We'll do one real quick. Here's we'll change this guy's name to pack H2O. And this guy could be, pack, PMML, etc., right? And then I would put the PMML operator here, and then I would unpack PMML, and then we could, output it and technically pass it downstream to whoever else you were going. You could union all those predictions and then say, look at this particular model predicted this other model predicted this other value.
That's
so
very powerful.
Before we leave here, let me just show you in H2O, we want the top level thing to be named frame.
Okay.
So that's kind of convenient. The H2O operator itself, on the models tab is where we name where is the model we're going to execute. So in this project, in my H2O project, I really do have a POJO that I'm going to use. I should say too, this particular, and we have a data file, audit.csv. So we've created the audit schema, and from that CSV. And so we're going to call that model, and from a schema point of view, what is the output going to be? So in H2O land, we list here the output. I'm just going to really emphasize again, you need to be friends with a data scientist who gives you the model, or you need to, say, hey, let me help you, but to help you, you have to help me help you, right? And get these details. In this case, what's happening here with this particular model in the data file, and it's publicly available. If you look at our data, if you look at our samples that we ship, we tell you where we got this data. You can see that we're auditing people. That this data file, if we open this up, let's see, open with Microsoft Excel. Hold, please. We see that we have some people in what we're predicting is whether they're going to be audited or not. And so this is actually our output is a string of whether they are a target of an audit or not. All right. And so that class value is the string, in essence, yes or no. And then the score is like a generated number where if your score is less than 0.5, you're not likely to be audited. If your score is 0.5 or higher, you are going to be audited. You're likely to be audited, I should say. So so that's what, again, we have to say, where is my model and what am I getting for output? And that's how you configure that guy. And then what do you think, my favorite student, what do you predict is going to be in this unpack? Well, let me help you. Let me give you a hint. With my focus on the model operator, I look at my streams and I look at the output. Let me even list this out for you. So what do you think is going to be in the unpack operator?
Class and score.
Okay. Very nice job. And again, our format is that we go into that scores list. You have to take the first element out of the list and get into the score tuple and then the class field, or in this case, the score.score. It's like we're stuttering. And so, I put it in the name of the field called target. Are you going to be the target of an audit or not? Right. So it's always the same pattern, right? Pack. Call the model, unpack.
Let me recap so to make sure I understood and also our audience has understood, right? So once you understand the pattern, it's quite simple regardless of your model type. So you are always taking the real-time data, transforming into a form that your model requires. So let's call it pack. And then once the scoring is done, you need to unpack that data so your further downstream can understand and take advantage of the predictions that's been made. So pack, score, unpack, and that's the pattern regardless of your model type. And there are some nuances between different model types in our operators, and that's very well documented in our documentation. So this is good.
All right, so the only other thing I'll add is that not only do you have the documentation set, but when you put the focus on the model operator, the streams pane over here in the right-hand corner is very helpful. You should lean on this to make sure that you take advantage. We're trying to help you and give you as many hints as we can about what this model is going to output, and then that helps you configure your unpack or your
Awesome.
extraction at the end.
That's great. So I'd like to thank you, Doctor, as always, very helpful. So with that, I think we'll call our session. And thank you, everybody, for joining. And we will see you in next session. Dr. Streaming, would you like to add anything else?
It's always great to be here with you, my friend.
Awesome. Thank you. Bye, everybody.